So our next unit of study is about precipitation, and the first part of that is going to be what we call atmospheric moisture. And you were given these set of research questions that you completed in class yesterday. This video is meant to be a self-check. You're going to watch through this video and make corrections if you see a different answer than what I tell you on the screen. First of all, what is atmospheric moisture? Just to clear this up, this is just about water in the air. That's what the whole set of questions was about what is water doing in the air. Defining and describing the process of evaporation. This is how water gets into the air. It's that process of evaporation. Evaporation is water that is turning from a liquid on the ground into a gas and being in the air. In order to do that, something has to happen because we're having a change. Water is changing where it's at.
So let's talk about how does water get up into the sky? How does it evaporate? Here I've got some water on the table. And we know that if we come back tomorrow, the next day, that there's a good chance that this water is going to be gone. It is going to have evaporated into the sky. And this happens in every lake, river, stream, and ocean out there across the planet. And that's how we get water into the air, which is what it takes to make precipitation. The question becomes, how does this water get in the air? What's making this happen? Well, it's changing. The water's here right now, and it's going to change where it's at. It's going to be up in the sky. Remember from our discussion of temperatures that in order for there to be any change, any kind of change, we've got to have some energy. Some energy has to go into the water, which allows it to then change, evaporate, and go into the sky. If I were to take this lamp and I turn it on and let the light shine on the water, I know that this water is going to evaporate quicker because the light bulb is giving more energy to the water, and more energy is going to make a quicker or a greater change. So in order for evaporation to happen, you have to have some input of energy in order to cause it to change from being on the ground to being up in the sky.
Now, out there in nature, we're not talking light bulbs. So we got puddles out here in this parking lot, and we know if we come back in a day or two, that puddle is going to be gone. It is going to have changed, which means there has to be some energy added. Well, in nature, remember that all energy comes from the sun. So what's required to make evaporation occur in nature is energy, specifically energy from the sun. But air pressure also affects evaporation, and we have high or low pressure. High pressure is pushing down on the water, which makes it hard for it to come up and get into the sky. So high pressure doesn't allow evaporation to happen as easily. On the other hand, low pressure, there isn't much pushing down now. And with lower air pressure not pushing down on the water can get up into the sky more easily. So you have more evaporation when you have low pressure.
So we know water evaporates, it gets up into the air. Whether it's water on the ground, like on this table in the parking lot, or it's water in a river, lake, or stream, we know it gets some energy specifically from the sun and it evaporates. It goes into the air. We say that air is always holding water because in this air right in front of me, there is a certain amount of water floating around with the air. Well, that means different air can hold different amounts of water. And we know the air is different at different times and in different places. So let's look at the number one thing that affects how much water air can hold. I want you to think about water as being a cup. And just like cups have many different sizes that can hold different amounts of water, different types of air can hold different amounts of water. The number one thing that affects how much water a sample of air can hold is the temperature. This cup here might represent something like 90-degree air. It's a big cup. It's hot air. Hot air can hold a lot more water because the air molecules are energized. They're moving so fast they can push around and carry and move a lot of water. Well, That there might be something like 75-degree air, where it's not as big as the 90-degree air. The air isn't as hot, so the air cannot hold as much water. And then you might have something like that, like 50-degree air, 40-degree air. So the amount of water that air can hold is, number one, determined by the temperature of the air. So the hotter the air, the more water it can hold.
So the first big conclusion here is that warmer air holds more water than cold air. Now, water in the air has a name. It is called humidity. Let's define what humidity is. Humidity is the actual amount of water that is in the air. And consider these two glasses. These two glasses are holding different amounts of water. So if these were two samples of air, we say they have different humidities because they're holding a different amount. The one over here would be a higher humidity. This one here would be a lower humidity. But actual humidity isn't that important to us. Here's what's actually a lot more important when we talk about the weather, and that is relative humidity. Relative humidity is how full the air is with water. So now consider this glass here and this glass here. They're two different samples of air, and they're different sizes because maybe they're different temperature air. But both of these glasses actually have 30 milliliters of water in them. But they don't look the same, even though the amount of water is the same in both of them. And the same is true with air. The one over here is pretty much full. This one over here is still pretty empty. What I've just described to you is relative humidity. Relative humidity is how full the air is with water, and that's the actual important variable that we want to examine. Relative humidity, how full the air is with water. Now, how is this expressed? This is always expressed as a percent. So this one here might be 95% full. This one might only be 35% full. That's how we describe relative humidity. We don't really actually care how much actual water is in the air. What we really care about is how full is the air with water, and that's relative humidity expressed as a percent. You can see it here. On this side we've got air holding a lot of water. It's holding almost all it can. It's 95% relative humidity. This one over here, this air is not holding very much water. It's only 10% full, so we'd say it has a 10% relative humidity. So a couple of funny cartoons. Water out of thin air, that's unbelievable. No, that's what humidity is. It's the water that is actually in the air. For those of you, especially girls, who straighten your hair, you'll find a lot of humor in this and a lot of reality in this cartoon. You wash and you straighten the hair, get the hair all looking nice and flat, and you walk outside, especially in Georgia, and poof, it frizzes up. And you can see the sentiment here that I've heard many times before, that you hate humidity because of what it does to your hair. You get it. Okay? If you don't have curly hair that you have straightened, this doesn't hold as much relevance to you. Low humidity days are good hair days, and high humidity days we tend to associate with bad hair days. There's actually something that the Weather Channel puts out called a hair cast, where they are describing the amount of humidity and how will your hair behave in those conditions. And it's actually funny because the first device to ever measure humidity was actually made from human hair. Right here. That's a strand of human hair, and you know that as the human hair soaks up water, the hair is going to curl up. It's not going to stay straight, which is going to pivot this thing. It's going to pull this thing up, and it's going to change where the needle is pointing. Well, if it's a nice dry day, my hair will straighten back out again. It's going to change where the needle is pointing. So that was the first device actually used to measure humidity, was how does human hair react in it. Now we don't use that anymore. We now use a device called a psychrometer. A psychrometer is the device that is used to measure relative humidity, or how full the air is with water. The most common one is called a sling psychrometer, because you take it, you sling it around in the air. Now, how does this humidity affect how you feel? Beyond what it does to your hair, how does it make you feel? Well, remember that your body sweats in order to get rid of heat. Your body's exercising. It's a hot day. It needs to cool itself down. So you sweat, and the sweat leaves your body, and it takes heat away from your body. And you can see that on your skin. Well, the quicker the sweat leaves your body, the better you feel. This is something called the heat index. The heat index is how hot it feels to you due to a combination of temperature and humidity. If you have high humidity and there's already a lot of water in the air, it's really hard for your body to get rid of its sweat. So the sweat stays on your body and the heat stays on your body, and you feel worse. Compare Las Vegas to Washington, D.C. Notice Las Vegas here has a temperature of 106, but yet with very low humidity, your sweat will leave your body so quickly that it actually feels cooler than it actually is. It feels like 99. Now, Washington, D.C. only has a temperature of 91, but with really high humidity, your sweat can't leave your body, so your body stays extra hot. And to your body, it actually feels like 102. Hanksville, Utah, a couple summers ago when I was there, was 101 degrees. It's pretty hot, but it only felt like 95 because the humidity was so low that as soon as your body sweat, the sweat left your body, and therefore it cooled you down so much quicker. It actually felt only like 95. So you hear this all the time about what is a dry heat. Well, this right here, that was my shirt after a 4-mile run at summer camp here in Georgia. It was about 90 degrees, and I ran about 4 miles, and that was all the sweat that stayed stuck in my shirt because it couldn't leave my body.
So I just finished another 4-mile run, and it's about 91, 92 degrees here. The difference is I'm in Salt Lake City, Utah, and the humidity is 14%, meaning all of this air is holding very, very little water. Well, what that does for me is it helps make it feel cooler for me, because the water will leave my body very quickly. Because this air isn't holding much water, it can come and grab my sweat and take it away from me. And when it takes it away from me, it takes the heat away from my body, so I feel much cooler. And you can actually see the difference. You can look at my arm and you can see I am sweating. My body put out about the same amount of sweat because I ran the same distance in the same temperature. So my body did the same amount of work, but it looks like I have sweat less. I haven't. The only difference here is that the sweat has left my body so much quicker here than it does in Georgia. And when the sweat leaves your body quickly, it helps to cool you down and makes you feel cooler. The opposite of that makes you feel hotter. You can especially tell, look at my shirt. You'll notice you don't see the outline of any sweat soaked into my shirt, because as fast as I was sweating, it was leaving my body. So that's like the opposite of the heat index, and how low humidity can actually make you feel cooler.
Now, a concept known as saturation. Saturation is when the air is full of water or it cannot hold anymore. And that leads us to our concept of dew. And you know what dew is. You've seen the water on the grass in the mornings, but you've probably never actually defined it, and you certainly don't understand the process.
Consider a sample of air and the water it is holding. Let's just say this is 75 degree air. This might be a early morning temperature where we are here in Georgia in the summertime, and the air is holding a certain amount of water. But as the sun comes up and the sun's out more, the air becomes more like this in late afternoon. It gets bigger. It can actually hold more water. And it does, because the sun's out. Not only does it have that amount of water in it, we have more and more water evaporating the whole day because it's a hot day and that sunlight makes more and more water evaporate. So I get to something like this by the end of the day. My hot 90-degree day, and I'm holding this much water. But what happens when the sun goes down? When the sun goes down, maybe my air gets to be this size. 50-degree air can't hold as much water as the 90-degree air. So the temperature starts to go down, and my air is holding its water, and now all of a sudden my air is full. My 50-degree air now can't hold any more water. But at sundown, it was holding this much. So what happens is this. My air is saturated, it's full, and all of the extra water that it picked up during the hot part of the day, it can't hold anymore. So where does it wind up? It winds up back here on the ground. The air can't hold it, so it drops it on the ground. When you get up, especially in the summer, and you go outside, you'll notice this water outside on the ground. It's on the grass, it's on your cars. Especially places where it's cool, you'll get water that ends up being dropped overnight because the air got cool enough that it can't hold it. That is what we call dew. And this is how dew is formed. Dew is formed when colder air overnight can't hold all of the water that it picked up during the hot day, so it dropped it.
Now, where do we usually see dew and why? Well, you see dew on the grass. You generally see it on the window of your car or even the hood or the top of your car. Well, why is that? Well, remember, in order for water to condense, it's got to get a little bit cooler. It was a gas and it goes back to being a liquid. That has to happen where it's cool. Well, the grass and the plants, they always stay fairly cool. They stay cooler than the air. So dew is going to form on colder surfaces like the grass or your windshield or the metal of your car. Next time you get up and you see dew on the ground, look at your driveway, look at the parking lot, look at the roads. You won't see dew on those surfaces because those surfaces stay a lot warmer because they soak up a lot more sunlight during the day. So you're going to get dew on colder surfaces like the grass and your vehicles.
All right, so here we've got some dew on the ground. It's pretty chilly this morning. It's in the 40s, and overnight the air couldn't hold all that water, and we can see it all out here on the ground. And the question becomes, what happens to this dew? We know the grass doesn't stay wet all day. And here's what we can see is happening. You can actually see evaporation happening. The dew is going back up into the air because now the sun is out, and we can actually see the water evaporating back up into the sky, where it'll stay in the sky all day until it gets cold again tomorrow morning, and then they'll drop it back on the ground.
This is why first thing in the morning your windshield might be wet, but you come out a little while later and all of the water has magically disappeared from your windshield, or it's magically disappeared from the grass because the sun comes out and now that water gets extra energy and it can go back through that evaporation process again. So define the dew point. The dew point is the actual temperature where the air starts to drop its water on the ground. And I took a snippet of the video because you could see, well, all the extra water that's going in there now is going onto the ground. In this case, we'd say the dew point was 50. If I was pouring that into the 75-degree cup, I wouldn't have had the overflow. I wouldn't have had the dew being formed because I wouldn't have been at that dew point. I wouldn't have been at that temperature where the air is full. So once again, the dew point is the temperature at which air is full of its water and it starts to drop it on the ground as dew. Now the dew point is actually one of the most convenient, one of the best predictors of how you will feel about the weather. And they use these kind of standard terms. If you have a dew point of 76 plus, in other words, it's only got to get down to 76 degrees before dew starts to form. That means the air is pretty full of water, and we say that feels miserable. It feels oppressive. Feels uncomfortable. Notice as the dew point goes down, you actually feel better because there's less water in the air, and therefore your sweat evaporates more easily and you feel better. You don't feel as hot and sticky and muggy. A dew point of 55 or less is considered to be pleasant. We don't get those a lot here in Georgia because our air just stays too wet. In the summertime, we very typically have dew points in the 70s, and this is why it feels so nasty in Georgia in the summertime. Now, what parts of the country have high humidity and what parts have low? We have low humidity in the west, and we have high humidity in the southeast, which you knew that about the southeast. You know it's very hot and humid here. You've heard that expression before.
So here it is, a nice summer morning in July. So let's go outside and try to find us some dew. And we'll look at this grass here and notice it doesn't seem like it has any water on it. No dew. As a matter of fact, I'll take some paper towels. You can see there's almost no water on it. So why no dew in this situation? That's because I'm in Palm Springs, California, which is in the middle of the desert. And even though it gets hot during the day, which would cause evaporation, and cooler overnight where water would then condense and form dew, there just isn't any water here in the air. So places in the west don't have dew like we have in the east because there just isn't enough water in the air to cool and condense on the grass overnight.
Now, how do plants affect humidity? Well, plants are important because plants take water from the ground, they bring it up through the roots, and they actually spit it out into the air. So places that have a lot of plants are going to have a higher humidity, as opposed to some place where if there aren't any plants taking water out of the ground, the water just stays in the ground and you would have lower humidity. So at this time, you have all of your answers to those research questions corrected. You have the right ideas, the right concepts. Now it's time for you to take the notes check on this presentation.